Okay, the first thing I'm going to do before I go over those last 3 homework problems from yesterday is just kind of review what the chain rule is and when to use it. Yeah, so it's used when you're trying to find derivatives of a composition of functions. And so you may think, well, what's a composition of functions? And that was just like, when you did the quick review 1 through 5 yesterday, where you had anything that says this, or it's where you have a function inside of another function. So like on the one from yesterday, f of x was the sine of x, and g of x was x squared plus 1. I'm not going to do h of x right now, just want you to get the idea here. And so, well, these mean the same thing, remember. So if I do this and I plug g in for f, so I plug this guy in for this x, I get sine of x squared plus 1. That is a composition of functions. There's an x in here, or I guess I should say, whenever you have sine, cosine, any of the trig functions, if there's anything more than just an x in there, then it's a composition. So if it's 2x, or if it's x squared, or anything more than just an x, or it could be a t, whatever your variable is, anything more than just a single variable inside there, you have a composition of functions. You're going to have to do chain rule whenever you see a trig function. So like this has more than just an x in there, so if we wanted to do the derivative of that, we would definitely have to do the chain rule. If we went the other way and plug this one in for here, same thing, we'd have the sine of x squared plus 1. Another way you notice when you have a composition of functions is if you have parentheses with an x, more than just an x inside, well, because you wouldn't put parentheses if it was just x squared. So if you have parentheses with stuff inside of there and it's squared, or any power out here, then you're going to have to do the chain rule. You have a composition of 2 functions. So like if you had x plus 1 in here, if you have sine of x, anything in here to a power with parentheses, you're going to have to use the chain rule. Same thing, if like you have the square root of x plus 1, and you want to do the derivative of that, you're going to have to realize that square root means the 1/2 power. We have more than just an x inside those parentheses and a power on the outside. We're going to have to do the chain rule. These are all composition of 2 functions. So the way we do that is, let's go back to this one, sine of x squared plus 1. Or maybe I should not do a trig first. Let's start with just easy, like, oh, okay, here, x plus, let's just make one up here. So let's say we have 2x plus whatever squared. We see we've got parentheses with stuff inside, we got a power, we're going to have to do chain rule. So here's how you use it. There's 2 different ways, and they're both the same thing. Some people find one way easier than the other, so that's why I'm going to show you both. Let's see, I don't know which one to start with. Let's go with just the inside-outside way. To do that, you just have to recognize, like, you have parentheses, here's your inside. You have a bunch of crap here on the inside. We'll call that the inside. And then on the outside, all you have is a squared. It's just this whole thing squared. So to do the chain rule, what you have to do is you have to do the derivative of the outside stuff. So you just ignore that stuff in there and say, if I have something squared, how do I do the derivative of that? And then after you've done that, you multiply it by the derivative of the stuff that's on the inside. So if I want to do the derivative of this, I think you all have this part down. This one's pretty simple. So derivative of the outside. So if I just, ignore all that stuff on the inside, if I do the derivative of the outside, this would just be power rule. I have something squared, so I move the 2 down in front. All that stuff stays in there. And then my power, I subtract 1, so 2 minus 1, that'd be the first power. Boom, I've done the derivative of the outside. Now I just have to multiply that by the derivative of the stuff on the inside. So on the inside we have 2x plus 3, derivative of that, derivative of 2x is just 2, derivative of 3 is nothing. I'd be done. 2 times 2 is 4. After this, you've done the derivative now, you got it right there. After that it's just simplifying, multiplying things together. So this is just 2 times 2 is 4, and then distributive property would be 8x plus 12, and you'd be done. So doing the trig function one, if we have something like that, recognize here the inside is this piece right here. So we're going to ignore that at first. And we're going to do the derivative of the outside. So derivative of sine. Derivative of sine is just cosine of, and you leave all that stuff in there. So that's the derivative of the outside. Wish I could use my hands when I did this. So yeah, derivative of sine, just cosine, same thing. Now multiply that by the derivative of the inside, which in this case is power rule. So it's just like, now you just ignore that and you think, okay, if I was just doing x squared plus 1, what's the derivative of that? Well, derivative of 1's nothing, so 2 times x, and then drop the power down, it'd be 2x. I think some of you get confused on how to simplify this. This is the cosine of x squared plus 1, so this always stays together, like I was explaining yesterday. Whenever you have sine or cosine, whatever's right after that, those always stay together. And that whole thing is multiplied by 2x. So the most common way of writing that, the most normal way, is to put the 2x in front. That's not incorrect, but this is just like standard way of writing it. I told you I was going to show you the other way. So it's using the u substitution, which is the exact same thing as doing the derivative of the outside and derivative of the inside. It's just a little different way of writing it. And this way you say, okay, here's my inside. So I'm just going to put a random letter and say u equals whatever is inside. So then I could rewrite this as just the sine of u. Well, now to do the derivative of this, it's still chain rule. The derivative of sine of u would just be the cosine of u. But then chain rule tells us now we have to multiply by the derivative of the inside. So we have to multiply by the derivative of u with respect to x. That's how you would write that. So now to write your answer, you just got to plug this back in. The cosine of u, well, u is just x squared plus 1, so I'd write x squared plus 1 times the derivative of u with respect to x. Oh, so I have to do the derivative of this thing. That's what this means. So this piece right here is the derivative of this. Alright, the derivative of u with respect to x, that'd be this. So I have to do it. So I can just do my work over here. The derivative of this is, oh, it's 2x. Oh, so this is just 2x. And look, I've come up with the same thing as here. So it's the same exact thing. It's just when we get later on and we get to some more complicated ones, this will actually end up being easier than, for right now, you'll probably all just do this, but later, I just want you to see this and know what it is so that when it comes up, you're not shocked. So sometimes we have to do chain rule multiple times and we have product rule going on. You just have to look at it and recognize what it is. So here's another one where you got multiple things going on at once. So, I don't Oh, I think I assigned that one. So I'll just make one up. This could get ugly, I have no idea. It's probably going to be one of those times where I'm like, bad example. Alright. So when you see something like this, first thing you should notice is, well, you're going to have to use quotient rule because you have things that are being divided. So let's just start there. Let's do our quotient rule and see what happens as we go forward with this thing. So let's see, quotient rule, I always say low d high, so low times the derivative of the top to bottom, square root of 2x plus 1, and right away you might want to rewrite this, because you know if you're trying to do the derivative, whenever you try to do a derivative of a square root, you're going to change it to 1/2 power. So let's just go ahead and rewrite it from the beginning. Just know going forward, if you're doing the derivative of something and there's a square root in there, every time you're going to change it to the 1/2 power. So I think you have one like that in the problems I assigned you yesterday. So you got here, we're going to do quotient rule. So if you're feeling good, you can pause it and try this first before I explain it. So low, so bottom, 2x plus 1 to the 1/2 power times the derivative of the top. Well, the derivative of 3x, that's easy. That's just 3. Minus, now we have the top, times the derivative of the bottom. But I'm going to hold off on that because I'm not going to have room to do my work right here, because when I look at this, I'm like, okay, now I have to do the derivative of the bottom. So you have to stop and think. What is the derivative of that? Oh, hey, look it. There's parentheses. There's more than just an x in here. There's a power out here. I'm going to have to do the chain rule. So we can go ahead and do that now. Or, well, I'm just going to put the bottom. You know, we have bottom times the derivative of the top minus top times derivative of the bottom. Hold on. And then on bottom here, back to my quotient rule, it's low squared. So 2x plus 1 to the 1/2 squared, which hopefully you realize 1/2 power squared is just 2x plus 1. Alright, square root of something squared is just itself. Okay, so this piece, the derivative of that. So let's go over here. Gotta do the derivative of that thing. So now, chain rule. Here's my inside. Remember, derivative of the outside times the derivative of the inside. If I do the derivative of the outside, so ignore that, something to the 1/2 power. How do I do the derivative of something to the 1/2 power? Well, you bring the power down and then you subtract 1 from the power. So I would have 1/2 times, leave the stuff inside, and then 1/2 minus 1 is negative 1/2. So there's the derivative of the outside. Now multiply that by the derivative of the inside. Inside of here, 2x plus 1, derivative of that would just be 2. So there, I've done it. Derivative of the outside is done. Multiplied by the derivative of the inside. Now I just simplify this. Well, 2 times 1/2 is just 1, so really those are gone. So I have 2x plus 1 to the negative 1/2 power, which we can leave it like that, or it'd probably be best, we don't like negative powers, to write it as 1 over 2x plus 1 to the 1/2. So there is my derivative of that. Weird how it's just the same thing, it's just 1 over. So that's what goes here, right? That's what we just did. We did the derivative of that, so that goes here. 1 over 2x plus 1, 1/2. Now we just gotta simplify this thing. As much as possible, don't freak out about this. Up here, there's really not much I can do with that. That's just 3 times this. So, I mean, you can't do distributive property because this is the 1/2 power. If you want to rewrite it with square roots, that's cool too. Let's just, I mean, you can't really cancel anything here because this is to the 1/2 power. This is 2x plus 1, plus you have subtraction in here. Actually, we could go crazy with it. Let's see. We got 3 times 2x plus 1 to the 1/2. This is just multiplication, right? So 3, I know a lot of you get confused when I do this. It's just multiplication of fractions. 3x over 1 times 1 over this. So it's going to be just minus 3x over 2x plus 1 to the 1/2 over 2x plus 1. We can make that simpler, actually. It's a great pre-calc problem now. So we're done with the calculus. We've done the derivative. I mean, we're done with that. We did our quotient rule. We did our chain rule. Now it's just simplifying. So I'm still going here. So now to simplify this, right, I'm going to ignore the bottom. Do my subtraction on the top. This is like review from last year. I'm going to have to get a common denominator. Alright, so in this case, I got 2x plus 1 to the 1/2 on bottom, so that's going to be my common denominator. And on top, let's see, this one's over 1, so I have to multiply the bottom by 2x plus 1 to the 1/2, so I got to multiply the top by 2x plus 1 to the 1/2. So I'm going to have 3 times 2x plus 1, right? So if I multiply the top of this by 2x plus 1 to the 1/2, it'd be 2x plus 1 to the 1/2 times 2x plus 1 to the 1/2, so it'd be 2x plus 1 to the 1. So there's that. Minus, this one already had the common denominator, so it doesn't need anything. And this whole thing now is still over 2x plus 1. Keep it on going here, do a little distributive properties, that'd be 6x. See, I'm running out of row. 6x plus 3 minus 3x over that stuff to the 1/2 over 2x plus 1. Alright, still got that. 6x minus 3x, so I have 3x plus 3 over 2x plus 1 to the 1/2. And that's all over 2x plus 1. So we can keep going here. Flip and multiply, right? A fraction divided by, that'd be like a fraction. So really we have 3x plus 3 over 2x plus 1 to the 1/2 times, flip that and multiply 1 over 2x plus 1. So our final answer is going to be 3x plus 3 over 2x plus 1 to the 1/2 times 2x plus 1 is going to be, remember, multiplying the same thing in parentheses, just add the power, so 1 plus 1/2 is 3/2. Now there's nothing else I can do. So most of that problem was just pre-calc, just simplifying a rational all the way to there. There will be no easier way to do that in the future. That's just an ugly derivative that requires a lot of simplification after you do your quotient rule. So now, I'll finally get to the problems we're mastering. Because some of these you have to do chain rule more than once. That'll happen sometimes. I didn't do a problem like that yet. So looking here, you go, okay, I want to do the derivative of this one. This is 22. Well, I see parentheses, I see a power on the outside. So boom, I know I don't have to do chain rule, let's just start there. So I'll ignore the inside. So derivative of the outside, pretty easy. Just drop the 2 down, I'll have 2 times, and I leave all this stuff on the inside. And then subtract 1 from the power, so that'd be to the first power. Boom, done. Derivative of the outside is done. Now I have to do multiplied by the derivative of the inside. Okay, so now when I look in here at 1 plus cosine of 2x, you should notice, hey, I have the cosine of more than just an x. I have cosine of 2x. You got to recognize, dang, I'm going to have to do chain rule again. So let's come over here, do some work on the side. I gotta get the derivative of that thing, my inside. And whenever I get my answer for the derivative of that, that's what's gonna go right here. Right, here's my derivative of the outside, derivative of the inside will go there, but I gotta figure it out. So, here we go, derivative. Whenever you're adding and subtracting things, you just do derivative of each piece. Derivative of 1 is 0, so I don't even care about that. Derivative of that. Put parentheses there if it helps you. Ignore the inside, do the derivative of the outside first. Derivative of cosine is negative sine. Leave the stuff in there. Boom. Done the derivative of the outside. Multiplied by the derivative of the inside. So the derivative of 2x is just 2. Write it like a normal person, and you have negative 2 sine 2x. Right? Because remember, these go together. That's multiplied by it. So usually just put it out in front. So there's my derivative of the inside, and that's what's going to go right here. Now we just simplify. I'm getting a little wobbly here. Hands getting tired. So let's see, what can we do here? This is multiplication. This looks ugly. Let's just... Remember, this is all multiplication, so it's 2 times all of this stuff. Don't need that power. Times negative 2 times. So remember, you can multiply stuff in any order. Sine always stays with that. Cosine always stays with that. Put parentheses around that if you like. The only thing I really want to do, I got a negative 2 in front, and this 2, let's just multiply those. I have 1 plus cosine 2x times sine 2x. You could distribute that if you wanted, but it's really, I mean, part of this is just recognizing when doing something will help, and when doing something is not going to lead you anywhere. You should recognize if you do the distributive property here with your sine, you're not going to get any further. Nothing's going to happen. You'll have sine of 2x plus sine of 2x times cosine of 2x, and you're not going to be able to do anything with that. It's not going to help. So like back here, when you have that big old ugly thing, you should recognize that, hey, I have subtraction, and I could get a common denominator, and I can get stuff together, and maybe when I get it together, divide by this, it'll all become, so it's part of recognizing when to keep going and when to stop. So on this one, maybe if you don't recognize that, this is a perfectly acceptable answer right here, by the way, because going forward, you should know nothing's going to happen. If you did this, if you went negative 4 and did times negative, oops, not negative, negative 4, and then did sine of 2x plus, and the way you would multiply those, you just write them next to each other. Sine of 2x times the cosine of 2x. Nothing happened. Or you could even go one step further and distribute the negative 4 and negative 4. Sine of 2x minus 4 times the sine of 2x times the cosine of 2x. Okay, cool. But nothing happened. Nothing got simpler. If you did that, though, that's not wrong. That's still a perfectly acceptable answer. It's the same thing. That's it for that one. Okay, next one. Hey, look it, we're going to have to do chain rule. We have parentheses with a whole bunch of crap inside, and we have power on the outside. I think this is the longest problem. Because you should notice, do the derivative of the outside, okay, easy. But then when you do the derivative of the inside, you got cosine squared. That sucks. We'll get to that in a second. Let's just go here. Derivative of the outside. Should just be 3. Leave the stuff on the inside. Drop the power. Remember, don't forget that power. You brought 3 down, subtract 1 from it, so you get squared. Boom, done. Derivative of the outside. Now inside. Uh-oh, this one could take a while. So now you have to do the derivative of that. And in order to do the derivative of that, there's one thing you have to know, which you're probably not aware of. Cosine squared of 7x is the same. You can rewrite that as the cosine of 7x all squared. These are the same thing, it's just written in a different format. The reason you would write it this way is because now you should see, oh hey, look it, I'm going to do chain rule. I got parentheses, stuff inside, and squared. So this problem you're actually going to end up doing chain rule 3 times. You got here, you're doing the outside times the derivative of the inside. Well then to do the derivative of the inside you're going to have to do chain rule. Because here's my inside piece. Then to do the derivative of inside of that you're going to have to do chain rule again. So it's just keeping track and knowing when you get your answer what that answer was. I know a lot of you struggle with that. You get an answer but then you don't know why you got it, you know how you got it, but you don't know what it is. So just remember here, maybe you can label, here's my inside and I'm trying to do the derivative of that. This one would be one where like the u thing might be easier. Might not be. I don't know. Okay, so let's do the derivative of this thing. We'll just say derivative with respect to x of this thing. Well, 1, that's just going to go away. So here we go. Derivative of the outside of this thing. I'm going to have to drop the 2 down. Times the cosine of 7x. Power is going to go to 1. Derivative of the inside. So the derivative of cosine of 7x. Hey, guess what? You have cosine of more than just an x, you're going to have to do chain rule again. So I'm going to need this piece. But in order to get it, I have to do the derivative of the cosine of 7x. More work. Cosine of 7x, got to do derivative of the outside, so derivative of just cosine, negative sine, times the derivative of the inside. Finally, it's easy. Derivative of the inside right here is just 7. So I have negative 7 times the sine of 7x. That's the derivative of the inside of this piece, so that's what goes here. Remember now what we were doing, this is the derivative of this. So this pen breaks. This was our derivative of this, which is what we want to do on here. So let's simplify this thing first. Negative 7 and 2, that'd be negative 14. Multiply them together, and then it's just cos of 7x times the sine of 7x. So we'll write just cos of 7x sine of 7x. So there's my derivative, finally, of the inside of that part, which I had to do chain rule 3 times total in this problem. So I got all of that. This is all multiplication. I have 3 times, well, all that stuff's squared, so I don't really want to mess with that. Again, knowing when to stop is key. All we can really do here, this is all just this negative 14 times this, so I can multiply the negative 4, and this is just multiplied by all of this, which is multiplied by the 3. So I can just write negative 14 times 3 is negative 42. Then all this, I don't want to do distributive property or anything crazy. Nothing good will become of that. Whoops. 1 plus. That's all squared. And then times, you don't need parentheses, you could, cos of 7x times sine 7x. Doesn't even really matter what order you have all this stuff in. But usually you put the number, just the number part in front, and then you have these 3 pieces that are just multiplied together. And that's your final answer for that one. That one's ugly. Last one. This one's not nearly as bad as that one. It's just doing chain rule twice. It's not bad. Like I said earlier, you see a square root, you should know, change it to the tangent of 5x to the 1/2 power. Now, do the derivative of that. I highly recommend you pause this one and try it if you haven't done it yet. Because this one's not bad. I feel like you could have success if you just remember what the derivative of tangent is. That one. See, I don't even know if I remember secant tangent. I think it's secant tangent. Or no, it's secant squared. I think it's secant squared. Yeah. Our quiz where you have to know all of those isn't until 4.3 and 4.4. I looked. Because then we're going to have like the derivative of c. Or I think we already told you all those. But you're going to have like inverse cosine and know the derivative of inverse cosine. So there's a whole bunch you have to memorize. So you're memorizing. Just realized that iPad ran out of memory, so it stopped recording. But that's okay, because I was just rambling on about your quiz later where you have to memorize stuff. So, but that'll be later, 4.3 and 4.4 sections. So back to this one, derivative of the outside, drop the 1/2, leave the stuff on the inside. Now remember always 1 minus 1/2. Or no, see, people do that, they mess up. Subtract 1 from the power, so 1/2 minus 1, you get negative 1/2. Done the derivative of the outside, so now derivative of the inside. So I have to do derivative of tangent of 5x. Ooh, this one is going to be 3 times, I was wrong. Because to do the derivative of tangent of 5x, come over here. You should see, oh, I have tangent of more than just an x. I'm going to have to do chain rule again. Okay, so the derivative of the outside, just tangent. Derivative of tangent is secant squared. Leave the stuff in there. So there's my derivative of the outside. Derivative of tangent is just secant squared. Times derivative of the stuff inside, which is just 5. So I have 5 times the secant squared of 5x. That's my derivative of tangent of 5x. So coming back here, when I was doing my derivative of the inside, I was looking for the derivative of the tangent of 5x. I found that. So there we go. 5 times the secant squared of 5x. So I've done all the calculus. Now I just need to simplify this thing. I see a negative 1/2 power. I don't like that. So let's see. I'll go. I won't skip steps. I have 1/2. Well, this to the negative 1/2 power. That's the same as move it to the bottom and make the power positive. Times, and this, I might as well write it as 5 secant squared of 5x over 1, because that'll make it look nicer. Because I'm multiplying all these fractions together. I have a fraction times that turned into a fraction times, might as well turn that into a fraction. That way it's easy to see. On top, you have 5. 1 times 1 times 5 secant squared of 5x. And on bottom, you have 2 times the tangent of 5x to the 1/2 power. So that's a good answer. Can't cancel anything or do anything with that. I guess you could, the only other way you could write it would be like that. That's good too. Put square root instead of the 1/2 power. So that's it. So that's all those problems. Some of them. I mean, the hardest part is just keeping organized. Keeping, okay, when I do Derivative of the outside times the derivative of the inside. Okay, when I'm trying to find my derivative of the inside, and I have to do chain rule multiple times, like knowing what you're doing, like, oh, when I get my derivative here, hey, that's what I wanted. I wanted the derivative of that. I got it, and so that's what goes there. Just keep yourself organized. Remember what you're doing. I think that's all I have to say about that. I gave you some more problems to try. If I remember correctly, they were number 4, 7. I don't think I gave you 12. I think I skipped 12. I think it was 4. I don't remember. It's like 4, 7, 13, 20. Maybe. That might be wrong. I don't remember. You're going to have to remind me on the next time we talk. So try whatever ones I gave you. If you don't have it down there, you can do those 4. I think it was only 4. That might have been right. Sorry this was so long, but I thought it needed to be.